Ben, what do you see? It's dripping.
Wet.
It's dripping wet. It's wet, right? So we talk about this decarboxylation, the Kracho Decarboxylation. We need to have wet DMSO.
Yep.
And we learned that wet means you must have water mixed with a DMSO and they can interact because of some kind of hydrogen bonding, right? Through this oxygen with H2O. I want to ask, why is it essential to have water?
So the essential part of the water is for the last part, to protonate the enolate.
So good point, because we need to do a protonation in the last part, right?
Yeah.
Can we add it stepwise? Can we start with DMSO first, right? Where it can also dissolve the sodium chloride, and then in the workup, we add the water.
I think it is not possible because we realize that what we have here is an enolate. And we realize that here we also have a 1,3-dicarbonyl and a side reaction might happen.
What's the side reaction?
Where you can do now let me draw the mechanism, it will be easier. So what we have is this, and we can have, let's say, on this end.
Yep.
So OMe, double bond and a R.
Reacts with itself, right?
Yeah, so it can react with itself, this double bond kicks down, and we form a new carbon-carbon bond.
Do you think it's more likely to attack? Right here.
Yeah, because methoxy is a good living group.
So in a way, it's like a... What's the product here?
So product here we have...
Take this.
We have a tricarbonyl group.
We are not having a trans esterification, right?
Yeah, it's not that. So...
so it's a 1,3,5...
tricarbonyl.
Yeah, tricarbonyl. Wow, this is cute. Reminds me of Monsters Inc. Okay then, cool. I'll see you next time.
See you. Bye bye.